Which term of the expansion of x to the 4th plus 4 to the 18th contains x to the 28th? Term number blank contains x to the 28th. All right, well, this is a binomial theorem question because we have two things to a big old whopping power. So that's the binomial theorem, two things to a big old power. So how are we going to find the term that contains x to the 28th power? That's a tough question. Well, what we could do normally, I like to make Pascal's triangle. But this one is so big, 18th power? Here, I've got Pascal's triangle I copied from a website. That's the biggest one I could find in my brief search on websites. See, that one goes down to 16, and then they have some words about all the patterns and stuff. But that one only goes down to 16. We need one. Notice this is 18th power, right? 18th power. This only goes down to 16. You would need two more rows. You could do them. 1, 17, what is this? 1, adding, I'm adding the numbers, but adding downward. 136. I do not feel like doing it. You see? Then I have to go down 118. There'd be our 1, and whatever this is. 150, 153, I think, and da. So there'd be there's the row we need. We need the 18 because we have an 18 power. So you would need to add two more rows to this biggest thing I could find in a brief search online, Pascal's triangle. So you need to go down to the 18th row. That's just big. That's too much. I don't feel like figuring out this 18th row here. So instead, I'm going to do it the other way. Remember, we had the other way, and that's going to be better when they give you a gigantic one, like 18th power. It's better to just use the parenthesis choose thing. I'll show you. Here we go. So what do? We remember you start with the power, 18, and you go 18, choose 0. 18, choose 1. 18, choose 2. 18, choose 3. And we'll figure out what those coefficients are in a minute. 18, choose 4. I'm just going to go all the way. First off, 18, choose 5, 18. These coefficients are what we normally get from Pascal's triangle on the 18th row. I just don't want to go all the way down and make the 18th row. That's a big pain. 18, 8, 18, 9, 18, 10, 18, 11, 18, 12, 18, 13. Hope we don't run out of room here. I think we're good. 18, 14, 18, 15, 18, 16, 18, 17, 18, 18. Okay, that's all of them. And then we put next to those the other terms, like x to the 4th. You start with the first term among the two in the binomial to the power, 18. And then x plus 4 to the 17. And you go down by 1 all the way. 16, 15. Oh, wait. What am I doing? I am getting totally confused and being a total wacko. Let's try this again. What am I doing? Sorry. Grab this first term here. So that is x to the 4th and then to the 18th. X to the 4th to the 17th. X to the 4th to the 16th. Right? You grab the first item to the power. So the x to the 4th to the 18, 17, 16, on down the line we go. And maybe it'd be good to figure out which one we want. We want which one now? 28th. Can you tell which one's the 28th? Well, it's a little further down, isn't it? 10, 9, 8. Oh, there it is. See, that one is going to be x to the 28th, isn't it? Because 4 times 7, right? Powers outside parentheses, multiply powers inside, right? That means x to the 4th 7 times. So that's 4 times 7, 28x. That's the x to the 28th term. What do they want now? They want what term number. So I don't even have to figure out the coefficients at all. So they just want the term number. Well, this is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term, 11th term, 12th. This is the 12th term. I didn't even figure out the rest of it. I didn't even do the second part to the whatever power. I found the one I needed, the x to the 28th. That's the 12th term. So just by following the pattern, term number 12 contains x to the 28th. So that's all we needed to do. We didn't need Pascal's giant triangle. I didn't even need to figure out the coefficients. I just had to follow the pattern. 12th term is x to the 28th.